Hello, Tigers. Today we are going to be working with solving two-step equations. That is our main idea. That is our I can for the day. Vocabulary is just two-step equation. You guys have worked with one-step equations. One step means that it takes one step to solve. Two-step means that, guess what? It takes two steps to solve. In order to solve this equation, we want to isolate the x or get it by itself. So in order to do that, we're going to subtract 1 on both sides of the equation. Shows you here that you're subtracting 1 on the left, you're subtracting 1 on the right. Also, something that I want to point out is that your equal signs are lined up, and they should be throughout this process. It's very important. Once you subtract the 1, then all that's left on the left side of the equation is going to be the 5x and then 26 minus 1 on the right. From 5x is equal to 25, you want to show dividing by 5 on both sides of the equation. And then the last thing is just x is equal to 5. So all of the steps are there for you. The only thing that you need to remember is x is equal to 5. Well, what does that mean? It means that 5 times our answer, 5 times x, which is 5, is equal to 25. And that should make sense. All right, 3x plus 2 is equal to 20. And so what I want you to do, because you don't really have a lot of space right underneath, is just to rewrite the problem. So we're going to say 3x plus 20 is equal to 20. We always want to think inverse operation. At the same time, I want to think, how can I get 3x by itself? Ultimately x, but for now, just how can I get 3x by itself? In order to do that, I'm going to write minus 2 on the left, and I'm going to write minus 2 on the right. Because this is a positive 2, in order to get rid of a positive 2, we have to subtract 2. So we're going to get rid of that. We're going to write 3x. I'm going to bring down my equal sign. Notice that my equal signs are lined up. On the right, I have 20 minus 2, which is equal to 18. Everything that I have written on my paper in terms of showing the work, you should too. So you should have negative 2. I'll just highlight it for you. You should have negative 2 on the left. You should have negative 2 on the right. And your equal signs should be lined up. The last step in this equation is to divide through by the coefficient. The coefficient is the number in front of the variable. So I'm going to divide by 3. The point of doing that is 3 divided by 3 is 1. I want it to be a 1x. Notice I've lined up my equal signs, and 18 divided by 3 gives me 6. I'm going to circle or box or cloud or do something fun with my final answer. And as you can see, this is going to tell us A is our final answer. Moving on to the next example. I'm always thinking about how to get the variable by itself. The variable is a letter that represents a number. So my thought process is, how do I get z by itself? In order to get z by itself, first of all, I've got to get 1/3 z by itself just to start with. And so in order to do that, then I have to get rid of whatever else is on the same side of the equation. I've got a positive 2, so I know that has to go away. That's the first step. So we're going to subtract 2 on both sides of the equation. And as you can see, and they wrote it a little differently, but you can just write it directly underneath. If I was doing this problem, that's what I would do. I would have written negative 2 and negative 2, or subtract 2. It's exactly the same thing. I want to write that on both sides of the equation. What's left is a negative 6 on the left and a 1/3 z on the right. In order to solve an equation, we have to multiply. Ultimately, I'm dividing by 1/3, but that just looks weird. I never write it that way. What I just did is a major no-no. We don't want to show dividing by the fraction. We know that dividing by a fraction is the same thing, you guessed it, as multiplying by the reciprocal. So to multiply by the reciprocal, we're going to multiply by 3 on both sides. In other words, 3 is a reciprocal of 1/3. All that's left on the right in this case is z, and 3 times -6 is -18. And I just feel like my answer isn't quite finalized until I turn it around and have my variable on the left. It's not wrong if you leave it on the right, but I prefer it to be on the left to finalize your answer. And if I was checking my work, I would be able to substitute that in. 1/3 of -18 is -6. -6 plus 2, of course, checks, and that's a -4. Let's go ahead and do the next example together. The process is so important in terms of solving a two-step equation. So I want you to rewrite it just as I'm doing. -5 is equal to 1/2 z plus 8. My thought process is I want to solve for z. Z is the variable. To get z by itself, I have to get rid of a positive 8. In order to get rid of positive 8, I'm going to subtract 8 on both sides of the equation. So I end up with -1/3 is equal to 1/2 z. I know that I always divide through by the coefficient, but when it's a fraction, it's going to look a little different. I love big parentheses, and I want to see big parentheses on both sides of your equation. I'm going to multiply by the reciprocal of 1/2, which is 2. And I want to do that not only on the right to eliminate or make 1/2 times 2 is actually 1z. That's exactly the direction we're headed. Then I also have to do it on the left. And a positive times a negative is going to give me a negative. Notice all along, you guys, that my equal signs are lined up. You don't have to get out your ruler, but you can see that they are in the same general vicinity of one another. And of course, you could go back and substitute in -26 for your z to see if you did that correctly. Please box or circle your final answer for me. And you should have C as in cat. All right, so 8 minus 3x is equal to 14. You see this problem on your PowerPoint. We want to get x by itself. In order to get x by itself, ultimately, I want to get x by itself, but really for now, we can think of this as a -3x. How do I get -3x by itself? Well, this is a positive 8, this number right here. How do I know? Because I don't see anything in front of it. So if I don't see anything in front of it, then obviously that's going to be positive. So to get there, we're going to subtract 8 on both sides of the equation. That cancels. -3x is equal to 6. This is really important. This was a -3x. You heard me say that a couple of seconds ago. So I have to make sure that I bring down all of that. It's like super glue. The negative sticks with the 3 and with the x. Why is that important? Because now I know that I divide by a -3 rather than a +3. As I go throughout, the x is left on the left, and I get a -2 on the right. If I was checking my work, 8 minus 3, I'm going to substitute in -2 is equal to 14. And so that's a -3 times a -2. That gives me a +6. And that does check, of course. Go ahead and pause the video, and I want you to go ahead and do the next one on your own. Once you have finished, then you can go ahead and start up the video. Welcome back. Some key points on this problem is I know I want to get my -2x by itself. In order to do that, I have to get rid of a +5. How do I know it's a +5? Because there wasn't a sign there to begin with. I added that 5 there. To get rid of a +5, I'm going to subtract 5. I do that on both sides of the equation. Notice that my equal signs are lined up, and I am working both sides of the equation. When I bring this down, this number is a -2x. Make sure you think of that as a -2x. -2x is going to travel down. That's very important because my coefficient is always the number I divide by. And if I don't bring down a -2x, then I will accidentally divide by a 2. So I have to be really careful with that. I hope that you've enjoyed your lesson on reviewing two-step equations.